it'd make things a little more sense to you guys if we explored that. So this is the graph. This is what the graph looks like. Oh, I almost forgot there's this little point here. So we call this f of x because it's actually a function. And f of x is a piecewise function, and it looks a little crazy. It's like x squared minus 1, comma, when we say negative 1, when x is from negative 1 to 0, then we say that the function is 2x when x lives from 0 to 1, and then we say 1 comma 1 when x equals 1, and then negative 2x plus 4 when x is between 1 and 2, and then x equals 0 when we go from 2 to 3. And so this is the domain of the function. So as we go through the domain in the x direction, based on the domain, we're going to apply different principles for our y values. So when we look at the piecewise function, we're saying when we go from negative 1 to 0, use this function, x squared minus 1, to get your corresponding y value. So if I were to graph that, let's try to, in other words, this right here is this function right here. Okay? Then it says, all right, that's cool. Let's go from 0. So when x is from 0 to 1, we're going to use the function 2x. And so what that is that's going to be from here to here. Well, when x equals 1, then our y value would be 1, and so that's that portion of the function right there. And I'm running out of colors. Let's use purple. Oh, I already used purple. What color have I not used? Green. Let's use the regular green. So when x goes from 1 to 2, let's use this function here. Negative 2x plus 4. And so that's that portion of the function there, which looks like the other green, because yellow and blue makes green, right? But you guys kind of understand what I'm doing with this, right? And then we'll use purple for the last part. Oh, we already used purple. Did I use? Yeah, I did for the little dot, but I could use it again. So then here it's just 0 from 2 to 3. So I've got this business going on. So each portion of my graph is defined by the domain, and we use different functions to represent our y values. So problem number 11 says, does f of negative 1 exist? Right? So here are some questions they're asking us. Part A says, does f of negative 1 exist? Now the backwards E is a fancy way of saying exist. Well, that means, can I find a value for negative 1? And the answer is yes. It's right here. Negative 1 comma 0. So I would say yes. Negative 1 comma 0. Part B says, does the limit as x approaches negative 1 from the positive direction of this function exist? So what I'm going to do is I'm going to approach negative 1 from positive infinity, right? This is positive infinity. This is negative infinity. So I'm going to approach it coming from the right-hand side. Does it have a one-sided limit? Yes. It approaches 0. Y approaches 0. Is f continuous at negative 1? Oh, I skipped C. Oh, this is C and B, right? So a more formal way to do this is to say that the limit which is 0. So that's kind of B and C. This is really part C here. So then part D says, is f continuous at -1? At x equals -1. Well, is it? So we want to say no, but technically the answer is yes, but it's a one-sided limit. It's an endpoint. So what we'd have to do is we'd have to go back and look in our textbook. And when we go in our textbook, when we define continuity at a point, it's continuous at an endpoint, right? The continuity at an endpoint means, can you get a limit coming from either the positive or negative direction, depending on which endpoint you're talking about? And we said yes, we could, right? So it's continuous, but it's continuity of an endpoint. And that's the only time that we can have something like that. Otherwise, we always said that the continuity is based on the limit as we approach from both sides, unless it's an endpoint. So as we look at this function, as we look at the graph, we could see that it is an endpoint and the limit coming from the opposing side. In other words, this endpoint is an endpoint on the left. So as we come from the right, there is a limit. So yes, this is continuous. It's an endpoint continuity, but it is continuous based on the definition in our textbook. Any other time, if any other type of continuity, when we're in questions 12 and I think all the way through 18, we'll ask you about continuity. Like it'll say, is it continuous here? Is it continuous here? Is it continuous here? And all those things. And there we have to consider the limit as it approaches from the two sides. Is it defined? So what is continuity? First and foremost, it has to have x in the domain, right? So whatever value we're looking at for x, that has to be part of the domain. Next, is it defined? Can I get a y value for it? If you don't have a y value for it, it's not continuous. Third part to that question, if x is in the domain, if y is defined, then does the limit approach that y value from both sides? Yes. If it's an endpoint from one side, yes. If you match up all three of those, then the function's continuous. Does that make sense?